will it ever be a different sign? No, the only way it could change signs is if it crossed what? The x-axis. We know it doesn't cross the x-axis and it is opening what? This is a parabola that opens what? Up, right? So if it never crosses the x-axis and it's opening up, that means that it's always what? Positive, so therefore it's always traveling in the right direction. So therefore the total distance will be the same as the net distance. Okay, so let's write all that down. So since v of t is greater than 0 for the interval 1.5 to what? 4? The particle is moving in the same direction. Therefore, total distance equals what? Net distance, which we know was 58 point what? 75 centimeters. Pretty good? Okay. We could have done that also if it was on the calculator section, just graph the velocity graph rate, and you would have seen a parabola above the x-axis all the time, so you know the velocity was always positive. Okay, and really it only matters, Althea, whether it changes direction on the given time interval, right? So it might change direction somewhere else, but I only care about whether it changes direction in that interval. Cool?
Wait.
I'm sorry. 2 more examples? One with E and one with trig?
Okay.
Your favorite? Alright. So again, here's another position function. They want the net distance or the displacement and the total distance. I'll help you with the displacement, okay? That's the easy one. So displacement, what would it equal? Absolute value of P of 0.5 minus P of 1.5. Okay, and again, we're given the position, and here it's measured in what?
Feet.
In feet. Okay, so what would I have to do to figure this out? Do the graph thing again. I'm going to press Control left to go back to the graph. I'm going to press Tab, and I'm going to call this function f8. So e to the 2x over to the right minus 8x. Now this is f8. Now I'm going to press Control right so I can go back to the calculator page and type it in. Practice. Absolute value, bars. Now I'm using f8 of 0.5 minus bars f8 of 1.5. What should we get? 9.367 feet. Very good. Papitas? Alright, so start the next one. What do I gotta do for that one? I gotta find the derivative, I gotta find where the velocity is equal to 0, make a sine line. Go for it. Find the derivative by hand at least. What would the derivative of e to the 2t minus 8t be? 2e to the 2t minus 8? Alright. So check for change in direction on the interval 0.5 to 1.5, right? So we're going to find p prime of t, which is the same as the velocity. And you said that was 2e to the 2t minus 8?
Yeah.
Okay? And we're going to set that equal to 0. And see if we can do that by hand up to a certain point, and then do it on the calculator. So we would say plus 8, right? Divide by 2. So we get e to the 2t is equal to what? 4. Okay, so I can't go any further than this. Remember when you were in pre-cal or algebra 2? You got to a point with an exponential function where you couldn't go any further. You had to rewrite it in another form, which would be, in this case, logarithmic form, right? Okay, so this would be like saying log base what? Okay, and we're gonna go the long way. So log base e of 4. Remember, logarithms are always equal to an exponent. So this log equation should equal to what? 2t. What is log base e? The same thing as ln, right? So we know this is just ln of 4 is equal to 2t. And then to get t by itself, I divide by what? 2. That's what I want you to enter in your calculator, okay? So ln of 4 divided by 2. There's going to be problems on the test where you will end up with equations or answers and they stay like that. Okay. T equals 0.693. Alright, so now just make your sign line, okay? I'm going to come back up here and I'm going to go V of t and I'm going to make my sign line. We got 0.5, we got 0.693, and we got 1.5. So we got to pick values in those given intervals to do a sign analysis of my velocity. So what would be something between 0.5 and 0.693? 0.6, alright, so get that 0.6, plug it into the velocity function which is right there, and tell me what you get, a positive or a negative. 0.6 times 2, what would that be? 1.2? Yeah, so e to the 1.2?
Negative, you got a negative.
You get a negative? Okay. So negative, check for sure on your calculator, that means the particle is moving to the what? To the left. Alright, between 0.693 and 1.5? 1? So e to the second times 2 minus 8, what do you think we should get? A positive. Oh man, so now it's moving to the what? To the right, okay? So I gotta do distances separated and then just add them, right? So I'm gonna do the distance from here to here plus the distance from there to there to find the total distance. Good? Let's do it. It's gonna be the absolute value of P of 0.5, right? Minus P of what? Good. Plus the absolute value of P of 0.693 minus P of 1.5. Finding the distance between 2 points where it was moving in the same direction plus the other distance. Do we already have that position function in our calculator? We already saved it, right? Remember whatever it was that you saved it as. Mine, I think, was F8. Right?
Yes.
I don't know what yours was. So you want to type it in. I'm going to go back and copy this one since it's already started. So it'll be f of 0.5 minus f of 0.693. Get out of the absolute value, put a plus. Absolute value of f8 of 0.693 minus bars f8 of 1.5. Bam! What do you guys get?
9.894.
9.894. That's my total distance. 9.894, and what would be my units? Kindergarten stuff? This is a lot nicer than the way we did it second. I didn't think of this until the end. I was like, oh wait, you could have done this. You guys are lucky. Right, if it had more places where it changed direction, then you would do each interval, right? And add them up. Okay, this is only if they provide you with the position function. If they provide you with the velocity function and they ask for this, then you would use it to prove it. It would be a lot easier. Good? Alright. Let's do one more with trig. So it says the position of a particle is given by this function measured in feet. Find the net and total distance between pi over 6 and 5 pi over 4. We good? Alright, so what would be my displacement here, Kristen? Absolute value of what?
Over 6.
P of pi over 6, right? Minus?
5 pi over 4.
Beautiful. Super easy? Let's do it. Now I gotta change the equation that I have in my calculator, right? Or I could just add another one, right? And remember what function it was. X plus 2 sine x. Let's see what you end up. What do we get for that displacement, guys? 0.989, and what will be the units? Feet. So did it move too much from where it started? No. Okay, cool. How do I do total distance? What do we have to check for first, Andrea?
If there was a change in direction on the opening.
Very good. If there was a change in direction on that interval, right? Okay, so in order to do that, we gotta find the derivative. So let's find the velocity function. What's the derivative of this function up here? 1 plus 2 cosine of t. We want to equal that to 0 to find out where it was at rest, which is the possible places where it could change direction. So that would be minus 1, right? And then divide by 2. So where does cosine equal to negative 1 over 2 on this interval, pi over 6 to 5 pi over 4? So we know pi over 6 is right here, right? And 5 pi over 4 would end up right in the middle of the third quadrant. So we're looking at this interval. From here to here, where would cosine be negative half?
Be 2 pi third.
2 pi thirds? So 2 pi over 3. Good? I'm so excited. I'm gonna learn calculus. They're mad because they're not in this class. Maybe that wasn't cute. Alright, so after this we make a sine line. So what would my velocity be? From pi over 6, right? To 2 pi thirds, all the way to 5 pi over 4. Okay, so pick something between pi over 6 and 2 pi over 3. Pi halves? Okay, so pi halves, plug it in. So cosine of pi halves? 0 times 2 is 0 plus 1? Positive, so the particle is moving to the right. Alright, hopefully it keeps moving to the right. Between 2 pi over 3 and 5 pi over 4? Pi, cosine of pi? Negative 1 times 2 is negative 2 plus 1? Now it's moving to the left. So I did change direction, so I need to find the distances of each one and add them up, okay? Let's do it. Total distance equals the absolute value of what?
Pi.
P of pi over 6 minus?
P of 2 pi third.
Beautiful. That's the first distance.
Plus absolute value.
Plus the absolute value.
P 2 pi third.
P of 2 pi over 3.
Minus P of 5 pi fourth. Plus 0.
Super easy.
Yeah.
Total distance and displacement is very easy. Type it in and let's see what we get. I think we'll stop there and let you work on your assignment. Unless you want to do more examples. No, is it fairly easy? Yes? Type it in. We already have that equation saved, or you should have it. So just use the vars to work it out.
You get 3.616. 617.
3 point what? 617? And the units would be what? Any questions? No? It's really easy? Excellent. And we got through it pretty quickly, so that was good. I hope it wasn't too bad. No? You survived? You made it through? Alright. So, I had 2 more examples to cover, but I think I'm gonna hold off on those and we'll do those tomorrow. Since tomorrow we're gonna do some AP questions in class. So we'll use those to get warmed up, then I'll give you the AP questions for you to work on, and then that should be it. After that, hopefully we should have a review, and then hopefully a test coming up soon. I wanna give it on Valentine's Day. Like my way of showing my love for you, okay?
You ever quiz scores?
Do I have your quiz scores? No, I'm sorry.
It's not worth $10.